So, welcome to a new video. Let's talk about heat management in a turbocharged application and what you can do about it, because, well, the exhaust components of a turbocharged car can get quite hot and will get quite hot. Upwards of a 900°C exhaust gas temperatures are going to result in probably glowing exhaust manifold and turbine housings. And this is where heat management comes in, or rather keeping the temperatures where they are supposed to be and not where they shouldn't be, for example on surrounding components such as the head or the firewall or some other miscellaneous stuff like, well, oil lines, water lines, etc., or boost pipes, for example. And this is where you can do different methods. A lot of people in the past have used exhaust wrap to wrap their components, for example manifolds, downpipes, even exhaust housings sometimes, but on exhaust housings most of the times turbo blankets were used, which also serve the same purpose. The issue with that is that while the turbo blankets are fine, they tend to be okay for that kind of stuff, the issue is more I have with the exhaust wrap, because that can trap moisture, and if oil or fluids spill on that, they can actually result in a fire. And the other problem is they will corrode the metal underneath, especially, for example, if it's not a stainless steel, and even if it is a stainless steel, because the stainless steel gets so hot it even corrodes that when moisture is trapped within that heat wrap, which can happen quite often, especially for example on Subarus, where the headers are on the bottom of the engine, or on downpipes on other cars, for example. The way to prevent that is not to use exhaust wrap, and there are a few different things you can do. And today I'm going to show you one of them, which is using thermal insulation material. So basically a fabric that is laid on top of the components, and that is insulating the temperatures and keeping them inside the components. And then on top there is this foil or stainless steel foil welded on top of that, and that traps the heat within. And this works really well. And it works so well that you can actually, after driving, maybe not after driving hard, but after driving normally, you can touch the exhaust manifold like this, or the turbine housing when it's insulated. So it works really, really well. The only issue we have with that is that it traps the heat so well that the parts within that get very, very hot, and even hotter than without anything. So you gotta keep that in mind. Don't run as high of exhaust gas temperatures, for example, to protect your parts. I wouldn't recommend this on very cheap hardware like China chargers from Max Speeding Rods, for example, because they can suffer from very high temperatures quite drastically, because they are just not specified for that. On Garrett stuff, for example, or like genuine Garrett turbochargers, it shouldn't be that much of an issue, but still be careful with, for example, a car that is driven very hard a lot of the time. This is basically more for a street car that needs to have good heat management, as for example in our case with the 4AGE engine. I'm going to show you how to do this job. While it's not very pretty, it's pretty cheap to do, and it's relatively easy. You can obviously, if you take a lot of time to make it nice, you can do it a lot nicer than this, and on a turbine housing it's also going to look a bit better, but this is still going to work like this, and it's going to cost you about maybe 50 bucks, if even that. The other option would be, if you don't want to do that and maybe you want the material to give off some of that residual heat, you could do ceramic coating, which is basically a coating that also traps heat within the components, but not to as high of a degree as for example this heat wrap, and it still gives off some radiant heat, and it does not hurt the components as much as you would, for example, with this, if you would use it in a motorsport application. And that's why a lot of headers, for example, in motorsport applications are in a lot of cases only ceramic coated and not wrapped with this. Though you can also see this in a lot of motorsport applications. And also in a few stock cars this has been done. It might look a bit different, yes, but still it has been done like that. What do you need to do this? Well, first of all, you need this kind of foil. This is 0.0 stainless steel foil. You can get this stuff for like 30 to 40 euros per square meter, and that's going to be enough for probably multiple cars. Even if you do the exhaust manifold, the turbo and the downpipe, even then it's going to be enough for 2 cars at least, I think. And you're going to need that type of wool. I'm going to put links for that in the description. There is stuff where that is glued to the back side of this, which here it was as well, but don't buy it like that. Buy it in separate pieces, because if you try to weld those together, and even if you overlap them like this, then it won't weld properly. So buy them separately, and that works much better. Then you just need a normal, the cheapest probably you can get will be enough, TIG welder. It doesn't even need to have high frequency or hot start. It just needs to be, yeah, just needs to work. And then I'm using a tip. Mine looks kind of bad already because I've already done a lot of stuff with it. But then you need just that tip, and basically sharpen that with an angle grinder to a point, or rather an edge, so that you can kind of go like this to give like a small line, because you have to contact the material and press it down with that line. And the smaller your edges, the less amperage you are going to need, and the better it's going to work. I'm going to show you this obviously when we are starting work. But yeah, just a tip like this. They aren't really expensive. They cost like $1 or $2 each, and then sharpen that basically kind of to an edge. Don't do it too sharp, because you will dull it down anyway, because you are going to press down on the material, but still should be like this. And you don't really need anything else. I would recommend some gloves, because that foil is really, really sharp and can cut you very, very easily. And yeah, so I would highly recommend that. And then degrease your exhaust housing or whatever component you want to wrap. And then I'm going to show you how to start. So I have degreased my exhaust housing, and we want to start by putting some stuff down on the edges. So like right down here, and on the other side, which we are going to do maybe first because you can see that better, is down here. Because we want to start laying some stuff flat down so that we can put the other stuff above it. And for that I already have my foil here, and I'm going to use a pair of side cutters to basically cut some lines. You want to be about, I don't know, like this. Then I'm gonna just cut a few lines here. And that is so thin that you can just, obviously if you want to get a cleaner line, you can also use a pair of scissors. Fabric scissors work pretty good for this. There you go. I've cut some different thicknesses because I probably am going to need a different thicknesses depending on where I am. And we are just going to basically do it kind of like this here. Obviously we do not want to go on this surface because there the turbo or the center section is going to clamp on. So we only need to go on this edge right here, or up to this edge. And yeah. So I'm going to turn on my welder. So, okay, I have sharpened my copper thingy to a relatively good edge. 110 amps, which should be enough for welding to the exhaust housing. If you are welded to the exhaust housing and welding these pieces on top of another with the insulating material in between, you need less amperage, about 50 to 60 would be enough. And yeah, I'm just going to start with that right now. We are going to lay it. We are going to lay it where we want to start. So right about here. And then we take our torch. Be sure to press on it, because if you are not, then it's going to burn up. And then while pressing, you can rock the torch back and forth. The issue is sometimes it may not stick very well, and then you just gotta try again. Oh, and I fucked up. So, okay, let's try again. I fucked up the first time. Let's try this again. Hopefully I'm going to do better now. Okay, all right, that sticks. It's not going to be sticking very much, but as you can see, it will stick. And then you just gotta go on that line. See, and that's something that you don't want to happen, want to happen, to get those sparks. So you gotta be really careful to only press on the button of your torch when you are actually making contact with both the foil and actually the exhaust housing. That's why you gotta press down, otherwise it will flake back at you. It sometimes happens that the torch will stick. Well, that can be very annoying, and it may rip out some foil. You may just have to patch it up. I hope you can see that all right. Ah, great. And where, for example, yeah, there you go. If you have done this and have any tips, let me know. I'm always appreciative of anything that comes my way. Okay, so as you can see, we are right now going to have to go down here and pressing it in. Maybe see, this is why you need to, and this is only the easier step. The more difficult one is to get this stuff actually to get actually the material to go inside, and then to get that sticking. So okay, I will just now explain to you what I'm going to do, and I will see you again when that's kind of more complete and I can show you the next step. Okay, so I have welded now some of that foil on the turbine housing. As you can see here, it's already overlapping so that I can weld here, here, and here when I put in my material for the heat insulation. So, while some other people use glue that sticks it on by itself, I'm just going to use a screwdriver and shove it in there. So that is my technique. You can do it however you want. I'm doing it this way. And you don't really need that much. This is too much. Even. The issue is because this is only a GT28 housing, there's not that much room for heat insulation itself. So we need to pack it in pretty tightly and into the small crevices here. I think I'm going to use some smaller thing and like put it in here, push it in there so that there is some stuff there too. Don't worry, this isn't as bad as the exhaust wrap, so it doesn't leave like glass wool splinters that will sting you everywhere. This is not nearly as bad. Although I think it's made out of a similar material, it won't be as bad as you would be used to if you have worked with exhaust wrap previously. So, and then we're going to shove where is the big piece I had right there. And there we go. That should suffice. Oh. There you go. The issue is we actually need it to be, we need some meat here to weld the weld it back on, so I need to leave some room, which can be quite tricky, but it's usually doable. So like this, and then we have heat insulation all over here. Obviously there's not going to be as much protection here or here, but you have to live with that. It doesn't go any, or doesn't get any better than this. It don't want to stick, damn it. Ah, boy. Great, great. It also kind of flashes when there is some insulation material below it, so that it doesn't want to stick at all. And this is also one of the reasons why not many people are doing it, because it can get quite frustrating. Because we're already at 150 amps. Turning it up to 180, maybe that helps. Seems to be a bit better at least. There you go, no. Come on. Why is my... There, thank you very much. Yes, nice. This is not going to, doesn't want to stick at all. Okay, this doesn't really doesn't want to stick. Okay, maybe I'll just weld up here now, so that gets easier. See, it's kind of tricky to get everything to stick correctly, so you gotta try multiple times, but yeah. So for these, I'm gonna reduce my amperage now to about 60 to 70 amps. And here it's the same process. Basically, you want to press together both materials and weld them together. Though this doesn't really want to weld here, so some more amperage. Actually, here you have to press the trigger. Oh boy, only not too long, because otherwise you are going to regret it and get sparks like this. This is not, that's not fun. But now you can actually kind of see where this is going. Yep, great. And you can see where actually the setup is going. So the issue is I can't get this to stick here, so I'm going to use another piece of foil and press this on and then use it to put it right here. So yeah, it's kind of difficult. So, okay, you have heard enough of me yabbering on, and I'm just going to show you some time-lapse of the footage I have captured while doing this. And I'm gonna talk to you a bit in the background about what you have to look out for as well. Basically, it's just a game of connecting all the pieces and shoving a bit of that insulation material below so that the heat cannot pass from the exhaust manifold or from the turbine housing or whatever you're insulating to the foil that is on the outside. And that is basically because of that material and also the air gap in between those two materials. If you are having trouble with welding the foil to the base material, then you can play around with the amperage and the duration you hold your welding torch onto the material, but that is just a thing of feeling it out, and you will need some practice to get it right. But luckily the materials aren't that expensive. As I said, for me it was around 50 bucks, and you can acquire a TIG welder on eBay or whatever for like a used one, a basic one, for like 100 to 150 bucks. And it may even work with different kinds of welders, such as electrode welder, but you might need to modify that in a different way. So yeah, keep that in mind, and you may be able to do it a bit cheaper. There's also tools like this one to make the whole job a lot easier, where you can basically, which is a wheel in front of your welding torch, and you can roll that basically over that foil, and that will weld that pretty much flawlessly if everything is set up correctly. I don't have that, and I don't know if it works that well because I've never tried it, but it might be worth a try if you want to do that more often. Anyway, if you have any questions about this and want to see maybe how it works, I may do a YouTube short on it once the turbo kit is installed on the engine, and then I can show it to you how it works in action. This video is more about showing how the whole process of wrapping the parts is going. Obviously I haven't finished this in this video, but I can show you the finished exhaust manifold, which took me about, I'd say, somewhere between 4 and 6 hours to complete. So yes, it is kind of time consuming, but it's still cheaper than getting it done by a professional, which would be about, I'd say, usually about 300 euros at least. That's it for this video, and as always, I wish you a nice day, and goodbye.